Now we have the sum and difference constant rules. Basically, if you take the derivative of two separate functions, whether they're being added and subtracted or multiplied by a constant, you would just take the derivative individually and put them back together. For example, we have this polynomial function here for part A. To find the derivative, we just take the derivative using the power rule of each part. So we get 3x squared minus 4, and then plus 5, that would be 0. Okay, you may need to rewrite it, or you may not. For this one, we have g prime of x equals negative 2x cubed plus 6x squared minus 5. Okay, this one, I think you will have to rewrite it since you don't know the quotient rule yet. So 2 divided by 2, that gives us 1. X cubed over x to the 1/2, that gives us x to the 5/2. And notice I labeled it y because I'm not taking the derivative. Okay, minus 3/2 x to the 3/2 plus 7/2 x to the 1/2 plus 5/2 x to the negative 1/2. Now we use the power rule. Okay, and I'm going to write dy dx. So we have 5/2 x to the 3/2 minus 9/4 x to the 1/2 plus 7/4 x to the negative 1/2 minus 5/4 x to the negative 3/2. And there you go. And again, you can rewrite it if you want so that it's a fraction, or don't. It's okay. I'll change the color here. We don't know how to multiply the products of functions yet. Find the derivative of the products of functions. So we're going to just have to multiply it out. So that'll be 9x squared plus 12x plus 4. And then I'll distribute that out. So we have y equals 9x cubed plus 12x squared plus 4x. Take the derivative, dy dx equals 27x squared plus 24x plus 4. And we're done. Now this is a really common problem that you're going to see. Find the equations of any horizontal tangents and the coordinates where they occur. So that whenever we're finding tangent, you're going to think derivative. Okay, so we have y equals x to the 4th minus 2x squared plus 2. The derivative would then be 4x cubed minus 4x. So if we want to find a horizontal tangent, the slope of that would be 0. If we factor out a 4x, we get x squared minus 1. So that would occur when x is 0, x is 1, or x is negative 1. So we're finding the coordinates and equations. We have one coordinate. If we plug in 0 to our original function, we get 2. So that would be a horizontal line, y equals 2. If you plug in 1, you get 1. That would be a horizontal line at y equals 1. Okay, and if you plug in negative 1, you also get 1. So we have y equals 1. So those are the horizontal tangent line equations, and these are the coordinates where we have horizontal tangents. This one is super common. You see it on the AP exam. You're going to see it on quizzes and tests. You're going to see it on worksheets. You have to use a lot of ideas and put them all together in order to solve this. But remember, when you're finding a tangent line equation, you only need two things. When the tangent line and the function, they intersect and they have two things in common. They have a y value in common and they have a slope value in common. So if you have this equation and you have this tangent line, at this point where they intersect, they have a y value or an x and a y value in common, and they have a slope. Okay? We need to find the values such that this is tangent to the graph of f of x. So we're going to start, let's look at the y values, because we know somewhere the y values are the same. So if I rewrite this, y equals negative 5x minus 9. Okay, and this, it would just be like y equals this. Okay. So we have negative 5x minus 9. That y value somewhere is going to be equal to this y value. Okay, if you want, we can move everything to one side to make it look a little easier. I'll just keep these separate. Plus 5x plus 8. Okay, so we need y values and we need slope values. Okay, slope. Remember, that's a derivative. In this case, the slope is negative 5. Okay, the derivative, see, that would be 4x plus k. Now, if we want to solve for x or k, we now have two equations, one here and one here. So we can use substitution. That'll probably be the most straightforward way. I'm going to make this a little bit smaller here, so it'll be easier to write. So I guess, what should we solve? I guess we'll solve for, since we're trying to find the value of k, we'll solve for k. K equals negative 4x minus 5. Okay, now we substitute it in here. 0 equals. Okay, instead of k, we're writing negative 4x minus 5. Now it's just some algebra work. Okay, that simplifies a little bit nicer. So we have 0 equals negative 2x squared plus 8. Solving that. X equals positive or negative 2. Now, remember what we were looking for. We were looking for the value of k. So we take our x value and plug it in. Plug it in to our k equation. So k equals, if we put in a positive 2, we'd get negative 8 minus 5, so we have negative 13. Or we plug in negative 2, so that would give us 8 minus 5, or 3. There you go. The important part about this was we had y values, we had to set them equal. We had slope values, we had to set them equal. Okay, and here are the two different solution curves. Notice this part, we got k equals 3, and this part, we got k equals negative 13. The last thing we're going to talk about is the sine and cosine rules. It's a really simple idea. The derivative of sine is cosine, which you saw in the calculator worksheet, and the derivative of cosine is negative sine. Add that in with our other rules, and it's not so bad. Okay, so if we find the derivative of this, derivative of sine is cosine. So the derivative of 2 sine is 2 cosine. And the derivative of plus 7 is 0. Derivative of x is 1. Derivative of cosine, negative sine. Okay, this one, again, we have the product of two functions. We don't know how to work with that yet. So what you have to do is use something else. So I'm going to rewrite this using the double angle identity, which says that sine of 2a, or x, whatever, is the same as 2 sine a cosine a. But you should know that. If you don't, work on it. So I can rewrite this equation as sine of x, because that's 2 times x over 2. So the derivative of that, cosine x. All right, last example we're going to do today. If f of x equals sine of x, find the slope of the graph That implies derivative at x equals 0. The derivative of sine is cosine. Plug in a 0. 1. Okay, and then let's see, f prime of 7 pi over 6 equals cosine of 7 pi over 6. If you know your special angles, then this isn't too difficult. Okay, this would put us in the third quadrant. So then we get negative root 3 over 2. And the last thing, all of the x values in between 0 and 2 pi, we need to figure out where f, sine of x, has horizontal tangents. You could draw a picture and try to figure it out, or we can use our derivative, which was cosine of x, and see where it equals 0. Okay, using your unit circle knowledge, you know that that would occur at pi over 2 and at 3 pi over 2. Now this was just asking for all x where it has horizontal tangents, so we don't need to go ahead and plug it in to get a coordinate in x and y. All right, have a great day.